All right, so here we're asked to solve each of the triangles and round your answer to the nearest hundredth. If no triangles exist, state no triangle. I'm realizing this video might be a little bit long because there could be lots of triangles to solve, but let's go ahead and go through this and try and see how quickly we can get it done. So triangle CAB, I'm given two angles and the side in between, it looks like. So I draw angle A here, which is 22. I'll call this one B here, which is 8. And angle C here, I don't know, but side C I know is 36. So remember that the lowercase values are opposite of the uppercase values, which are angles. So when I'm going through this, I need a couple different things. I need, first off, this angle here, and then these two sides. So I'm going to start with the angle because since I have two angles, I'm just going to subtract them both from 180, and that tells me that angle C is 150. So angle C equals 150. There's my first piece of information. Now I'm going to go ahead and use the law of sines to help me solve the other two. So in this situation, I'll go ahead and solve for side A first. Side A, using the law of sines, I'm going to get 36 over sine of 150 because I just used the angles and the opposite sides of those angles. So multiply sine of 22 on both sides. Now I just plug all this junk into a calculator. 36 times sine of 22 divided by sine of 150. And that gives me my A value of about, I'm rounding this here, 26.97. And lastly, I got to find side B. Do the exact same thing that I did for side A, using the law of sines. So I multiply both sides by sine of 8. And I plug all this into a calculator. So 36 times sine of 8 divided by sine of 150. And that gives me my B value of 10.02. Now, just to double check our work here, because I want to make sure that all of these answers make sense. When I look at these, my smallest angle is 8 here, and it projects to the smallest side of 10, which is good. My largest angle, 150, projects to the largest side, which is 36. So all my numbers seem to check out. So my first triangle is solved. Now, for the next one here, I'm given 3 different sides. So I know actually just from me having done this a lot, when I'm given 3 different sides, I know I'm going to need to use the law of cosines because I can't use the law of sines since I don't have any angles. So in this one here, let me just make sure I graph this or I plot this correctly here. So this is R, this is P. Okay, so when I'm going through this, I need to use the law of sines to find an angle. So I'm going to go ahead. I always like to find the largest angle because it eliminates the most mistakes here. So 26.7 squared equals 16.7 squared plus 17.3 squared. Ooh, this is going to get messy. Minus 2 times 16.7 times 17.3 times cosine of the angle that I'm looking for, which in this case is P. So I'm going to take a second here to plug some of this into a calculator to simplify it a little bit, and then we'll walk through the steps after that. Okay, so now I've done 26.7 squared, then I added together these two things, and then I multiplied together these three things to have my kind of simplified version here. Next thing I'm going to do is subtract 578.18 from both sides, and that ends up giving me 134.71 equals negative 577.82 cosine of P. Then I'm going to divide both sides by negative 577.82, which ends up, I'm rounding here, but I'm going to use the exact value in my calculator, But I get about negative 0.233 equals cosine of P. And then I take the inverse cosine of both sides to get P, which is about 103.48 as my angle here. So 103.48 for angle P. Okay, so from here, now I'm going to use the law of sines to help me out and solve my other angle. So in this case here, I'll go ahead. Again, I like to go from biggest to smallest. So now I'm going to solve for angle Q. So sine of angle Q over 17.3 is equal to sine of 103.48 over 26.7. I just used angle P and side P. So now I multiply both sides by 17.3. And then I'll take the inverse sine of that. So really angle Q here is going to be the inverse sine of 17.3 times sine of 103.48 all over 26.7. And so what I end up getting for Q is about 39.06, it looks like, for angle Q. And now my last one, because I have these two angles, I'm going to go ahead and just subtract them from 180. So 180 minus 103.48, there's the bell, minus 39.06. And then my final angle, I think it was angle R, yeah. Angle R is equal to about 37.46. So there are all of my angles, and now I have my second triangle solved.